So lesson 1-2. Start a little bit. We're not going to get much, but that's all right, right? Do what we can here. You won't be able to do any homework yet, I don't think. That's fine. So we're going to look at limits, okay? As I said, there are 3 big topics in calculus, and the first limit, or the first topic is limits. So everything we can learn about limits. Limits are the backbone of understanding that connect algebra and geometry to the mathematics of calculus. In basic terms, a limit is just a statement that tells you what height a function intends to reach as you get close to a specific x value. Recall from pre-calculus that you evaluated 3 types of limits, and we're going to complete the table below, okay? And part of what we're going to look at here, which this is important, what is proper notation? How do you write a limit? Because we have to be specific, because when it comes to AP exam, that's not me grading it. Okay, that's an AP grader, and if they want to be specific and your format doesn't match, it doesn't have to work for them. So we need to talk about limits. And as we talk about limits, I'm going to use a number of c. That's the number we're going to talk about here. And our function is f of x. So I'm going to jump down here for the moment to the general limit. If we talk about a general limit, limit notation is the limit as x approaches some number, which I'm going to call c, of f of x. So that is the limit as x approaches c of f of x. That c is an x value. So as you move towards c on the graph, what is your function value? So what is your y value? That's what we're asking. And this one verbally is the limit as x approaches c. Okay, in words, it's the limit as x approaches c. Now, we did talk left hand and right hand last year, or no? I'm trying to remember.
Approaching from the left.
Yeah, approaching from the left or approaching from the right. I don't know. I feel like maybe we did, but maybe it's got this. So notation-wise, if we want the limit as x approaches c from the right, if we're approaching from the right, we're coming from the positive direction. So you put a little plus sign in the exponent spot or the subscript spot. And so what this is, the limit as x approaches some number c from the right. So when you see that plus sign after the number, the limit as x approaches c from the right. And again, I can't remember. I sometimes confuse pre-calc and calc curriculum. What have I taught? What have I not? So what am I going to do for left-hand limit? Limit as x approaches c from the left is going to be indicated with a negative sign. It's not a negative sign in front of c. It's a negative sign in the wouldn't be subscript, it'd be superscript, wouldn't it? The exponent spot. And this is, of course, the limit as x approaches c from the left. Okay. Well, we'll look a little bit at the bottom, but this is where we're going to get stopped. But as I said, I want to use our time. Okay. Limit form, guys. We'll write this limit form, okay? Don't make it funky. Use my limit form, because that is the standard accepted limit form. Okay, so some of this is definitely reviewed here. Use the equation for f of x and graph of the function to analyze completely. So we're going to talk about all these pieces. Now, factor and simplify. Do you remember why factoring is important here? Yeah, factors are going to help me with several of these pieces, aren't they? What are you thinking? No? What about x squared minus 9? Can we at least factor that one?
No. X plus 3x minus 3.
Yeah, the top is product of AC. Now, you guys aren't going to like this, but what if I skip product of AC and do more of a guess and check thing? I always try this with calculus, and a lot of times you guys still like your product of AC, which, fine, so be it. Use product of AC. But, okay, the front pieces down below multiply to be x squared, right? Up top, they multiply to be 3x squared. Well, what are my options for multiplying to be 3x squared?
3x and x.
3x and x, right? Is there any other option? No. So I know my first pieces are going to have to be 3x and x. Now, my c value, because that's what values go at the end of the parentheses, right? What are my options for multiplying to be 3? 1 and 3. Now, technically, we have two options. 1 and 3 or 3 and 1. And this is where you place them so that we get that 8 for our middle term. So when you multiply your outsides and your insides, they work to be 8. So, and here's the other little hint I'll give you. Unless there's a GCF up here, I know 3 can't go here because then there'd be a GCF here. So I know it's going to have to be 1 and 3. If it multiplies to be a negative 3, I need a positive and a negative. I also need to get a negative 8 here. So this is where I personally look, okay, my outsides are going to be 9x. My insides are going to be 1x, right? I'm foiling, yes? So if my outsides are 3 or 9x, I want 9x to be negative, don't I? So how do I make 9x negative? I'm going to have the minus in front of the 3, the plus in front of the 1. If you try that guess and check after a bit, it works. Now, this was an easy one. Obviously, when there's lots of choices, it's harder, but, or product of AC, it still works, right? So factor and simplify. What are we simplifying here? X minus 3's cancel. So this simplifies to be 3x plus 1 over x plus 3, right? Okay. What did that simplifying do for me?
There's a hole.
There's a hole or something like that, right? Where is there a hole? At 3, yes? There's a hole at 3 because it's where x minus 3, right? So if I take x minus 3 and set it equal to 0, right? That was the trick I showed you. So there's a hole at x equals 3. Now, for later, you need the coordinates there. So there's a hole, because it actually says coordinates of the hole. 3, comma, how do I get the other coordinate? Take 3. You can plug it into the original. You can plug it into the factored or the simplified. I'm going for the simplified. So if I plug in 3, 10 over 6, and 10 over 6 reduces to 5/3. Could you technically leave it 10/6?
Yes.
I don't know. For working purposes, I always preferred simplified, but okay, so this is a hole, right? This is also remember the word discontinuity? Okay. We called it a removable discontinuity. I noticed in this curriculum, they also call it a point discontinuity. Same thing. Okay, so if you want a little bit of a reminder, it is a removable or point discontinuity. Okay? So, a little bit of vocabulary there. Let's jump. Vertical asymptote. Where's there a vertical asymptote?
At x equals negative.
Yeah, do you see it right here? There's a vertical asymptote at x equals -3. How can we know that by looking at the equation? Set your denominator equal to 0 also, yes? Is this all coming back to you in a big, like, oh, wow, yeah. Yeah. So this could also be, besides looking at the graph, there is the denominator equal to 0. Okay. What about horizontal asymptote? If you cheat and look at the graph, it's what? It's not cheating, but it's y equals 3, yes? Do you remember how to look at your what? First terms? The powers match, so what is it? Yeah. Yeah. Oops. Powers match, so it is 3. Okay? We'll fill in domain and range tomorrow. Maybe I'll get lucky and we won't erase overnight. And then we will talk about limits. I like limits. As I said, I like this lesson. I think you guys will like it once we get into it. Pretty good one.